The very last concept we're going to talk about this year in Algebra 1 is a concept called arithmetic sequences. You've actually already looked at sequences many times in the past where you have a series of numbers and your job is to find the pattern. How are we getting from 3 to 5 to 7 to 9, 11? Well, you can clearly see we're just adding 2 every time, which means there is a common difference between the terms. That common number is 2. Over here, to get from 33 to 29, 25, 21, 17, and so on, we're just subtracting 4. If you can find that pattern between a series of numbers, it's considered to be an arithmetic sequence. Here's a couple more examples. Here you can see that we're adding 2, adding 2, adding 2. However, on the next one, we add 1/8, we add 1/8, and then we add 1/16. Because we've changed what we are adding, it is not a common difference, and therefore this is not, example B is not an arithmetic sequence. On 1A, we add 4 to get from -26 to -22. We add 4 again. We add 4. So given this series of numbers, we would say yes, it is an arithmetic sequence. Right here, we add 3. Then we add 5. Then we add, 16. So this one clearly is not. We actually knew right there, going from 4 to 9, when we did not add 3. So this one is not an arithmetic sequence. We can look at patterns and use this common difference to find the next 3 terms of an arithmetic sequence. So right here, if we continue this pattern of subtract 6, subtract 6, subtract 6, we will find the next 3 terms. So if I have -3, take away 6, I get -9. Take away 6, -15. Take away 6, -21. Similarly, right here, the next 4 terms, going from 9.5 to 11, we add 1.5, add 1.5, add 1.5. If we do that again, three more times, we get the next 3 terms. So this would be 15.5, add 1.5 would be 17, add 1.5, 18.5. This next sequence here, you can clearly see that we are adding 3, add 3, add 3. So to come up with the next 3 terms, not too challenging. What if it wanted the 101st term? That would be a bit cumbersome to continue to add 3 over and over and over until you get 101 numbers. It's not very realistic, and yet that's what we need sometimes out of these situations. So because of that, we can actually cook up a formula that can be used instead. So you can see here in this example, the first term is 8. First term, 8. The second term is 8 plus 3. 8 plus 3. 3 is the common difference. The third term is 8 plus 6, or 2 common differences. The fourth term is 8 plus 3 common differences. So you can see here, based on the pattern that we're creating, we always start with the first term, and then on the second term we add 1 difference, the third term we add 2 differences, the fourth term we add 3 differences. The number of differences that we add for each term is 1 less than the term we're on. When we're on the 4th term, we add 3 common differences. When we're on the 3rd term, we add 2 common differences. So the final formula that we develop from this is right here. A plus 1 plus the quantity n minus 1 times the common difference. Here it is written again in our key concept book, our little box here. Let's practice using that information to now write a arithmetic sequence formula and find the nth term. So for this example here, our first term, a sub 1, is negative 12. Our common difference is add 4, so positive 4. Then we just simply copy down the rest of the formula that never changes. We like to simplify this formula, so negative 12, the 4 will distribute, plus 4n, take away 4. And then we have some like terms here that we can combine. So we would say 4n minus 16 for our final arithmetic sequence formula. Now we can use this formula to find the 9th term. We don't have to add 4 over and over and over. We can just use this formula. So a sub n is 4n minus 16. We're going to replace n with 9 because it wants the 9th term. This makes 36 minus 16, which is just 20. Right here, they're actually asking us which number term would be 32. So again, we take our master formula, 4n minus 16, but we're going to put a 32 on this side, on the left side of the equation, and solve for n. So if we add 16 to both sides, we get 48 equals 4n, and then dividing by 4 on both sides, n equals 12. So the 12th term is 32. All right, let's write an equation for this one. A sub n equals a sub 1, which in this case is 3, the first term. That's always a sub 1. Going back to our formula. This is our formula we're using. A sub n is a sub 1 plus the quantity n minus 1 times the common difference. N minus 1 times our common difference. We are subtracting 13, subtracting 13, subtracting 13. So the common difference is subtract 13. You really need to put it in parentheses like this so that you can see to distribute it and not mistake it for subtraction. So a sub n is 3 minus 13n plus 13. A sub n is negative 13n plus 16. Now if we want to find the 15th term, that would be a sub 15. We replace n with a 15 in our formula and simplify. So 13 times 15, using the calculator here, negative 13 times 15 is negative 195 plus 16 would give us negative 179. Which term is negative 114? So now we know the term, we put it on the left side, and we take the right side of our formula and copy it. We need to subtract 16 from both sides. Which is negative 130. Let's try this again. OneNote kind of shut down on me. Let me catch up to what I had written. 10 equals n, so the 10th term. That's what I was trying to write before OneNote got a little buggy on me. The 10th term is negative 114.